also create some other boundary conditions. So if we go to Insert, Boundary, and so the name, we're going to call this Wall, and hit OK. And so the boundary type, we want this to be a wall, and location is, out of all the, it already recognizes our different components, we want it to be a wall. And then we go to boundary details, and this is on the tutorial, by the way, so you can just look at the PDF to get this. We want it to be a free slip wall, and adiabatic. I always, how do you pronounce this word? Adiabatic. I always say it wrong. I'm embarrassed. I can't even pronounce this. What kind of engineer am I? Adiabatic. Okay, so once we have that set up, we hit OK. And so now we have our wall. We're going to insert another one, another boundary. I'm actually going to go out of order a little bit. I'm going to do number 35 on the tutorial, which is where you make the body. Now this one, I've updated the tutorial, and so the new one we'll have to put on TCC. There's a little thing that just doesn't explain real well. So we're going to call this one Body, for the body of the car. And for body, we want the body to also be a wall. And then location is default exterior. That's what's hard to catch. And you'll notice when we select default exterior that the outside of the car turns green. If you select different things here, like the wall, you can barely see it, but there's a little bit of green on here on the top and on the bottom. So default exterior is the exterior of our car. And then boundary details, we also want this one to be a no-slip wall and a smooth wall. So click OK, and it made our body. Going back to 34 on the tutorial, we're going to insert another boundary, and this one we're going to call Symmetry. Symmetry. Okay. Now this one is, the boundary type is Symmetry, and location for this. Now, there are a lot of these. If you click the dot button, you can see there's a lot of different ones, a lot of different primitives. And to be honest, I don't know why it made so many of these copies. Like some of them are like this, other ones just look like there's something else. I had success. Okay, the tutorial says to select like all of them. But I've had success just selecting one. I did it on primitive 2DB, and that worked for me. So I'm going to do that again. And click OK. And okay, now we just got to make sure we got to make sure that the inlet and the outlet are correct. So if we double click on outlet, or you can right click and say edit, I think. Edit, and it'll bring up the same thing. So it is an outlet, and its location is outlet. That's correct. Boundary details, I want to make sure it's subsonic, average static pressure, 0, 0.5, average over whole outlet. So looks like we're good for that. Hit OK. Then inlet, double click or right click and say edit. This is good. So boundary details, subsonic, normal speed, medium intensity is good. Now here, normal speed, this is where you can set how fast the air is moving. So in the tutorial, he has us set it to miles per hour and 30 miles an hour. Really, you can set this to whatever you want. So if you want to test at different speeds, you can go ahead and go for that. So that's the place where you can modify that. And we're going to hit OK. And then everything's basically set up to go. We just need to modify a few things. So is everyone at that point now? Have you got all the boundaries set up? Okay, so now there's a button up here. The next step, 38 on the tutorial, is set up your solver by clicking the solver control button on the toolbar. So click on this. It'll bring up this stuff, and most of it there's only one thing we need to change. A high resolution, first order, 1 to 100. We're going to change auto timescale to physical timescale. And we're going to change that. We're going to make that 2 seconds. The rest of it looks good. So we're going to hit OK. And then the last thing, we're going to define the solver run by clicking this button, which is the define run button. And so now we show where we want to save it. I think this is the same place I want to save it at. So let's see. Yeah. So I hit save. And once we exit that, the CFS solver manager will automatically open. And we want to run it, and it looks like everything's good. Just make sure this is to the same. Oh, I didn't even name it, so it's unnamed. And once we're ready, then we say start run. And this hopefully won't take too long. Remember how we modified the mesh on the BL2D mesh thing? Instead of being like 0.001, we just changed it to like 0.01. Like, I think that made it a thicker mesh. Because last time I did this, it took me like half an hour to solve.
Did we change anything?
No, as long as the file path is right, you can go. So yeah, and so then that's all I'm really going to show. The last couple steps on the tutorial show how to view a contour plot, which is really, really easy. And so I'm sure you guys can figure that out very easily. And then here is the picture that I saved after I finished of the result of this 30 mile an hour on this same thing.
So what does that mean?
Well, this is in meters per second, the speed. And so it looks like it all comes in about the same speed, and as it goes over here, it's a higher, there's a velocity contour plot at least. And so it's going 2 meters a second in here. I guess we could have changed that to be better units instead of, because we set it at miles per hour. So you could probably do that in the contour plot. So this just shows how the flow is over the whole car. So obviously where there's more, you can see where the drag is and stuff, I suppose.
Can we do a contour plot that shows
yeah. So if you look at the last page of the tutorial, the step 44, when you are setting the contour, it says set symmetry for the locations and set velocity as the variable. So you should be able to set that velocity as, or instead of velocity, maybe you can do pressure or something like that. You should be able to do that. I haven't tried it, but that should work.
Mine's done, so you should find that.
Oh yeah? Let's check it out. Oh, beautiful. Okay, that was much, much faster than I did before. So we should be able just to close this. And then we go to, let's see what does it say. Oh, did it bring up any other? No. So we open up CF post. Let's go to CFD post. There should be a dialog box that pops up, and you can just click post process results. Okay, so and if we load some results, that's probably what we're looking for. If you just check the box, it does it all for you.
Which one do you use? The .dev,
I don't know. I'm finding out. Last time I just checked there should be a dialog box that pops up, and you can just click close, like post process results. You can just open it up. So hopefully this will work. If not, it's one of those files. We can figure out which one it is. Pre-post. Okay, great.
Which one was that then?
This was the .res file. I figured that must have been the results. So here's symmetry. Outlet. Actually, I don't think we need to check these. We could probably just leave it blank. And then if we say insert contour, call it contour 1 or whatever, and so locations, we want to set symmetry, and it says to set velocity as the contour. I'm going to try pressure here though, see what happens, and I think that's it. Apply. And look at that. There's our contour plot with pressures. So, all right, or we should be able to, let's try the velocity one. Apply. All right, and there's our velocity.
So when we do the insert, where do we do that under? For insert.
Insert contour. All right, so I'll just be going around helping you guys for the rest of the time here so we can do this.